shenanigans going on. It's not using bean style getters and setters. This is where I think bean property, or $bean, or not dollar, but @bean, will tell the compiler to generate getters and setters in standard like Spring style. So, which is sometimes necessary, unfortunately. So we can see that we're doing A right. We can see that we're doing B in a way that we expect because he's a val. What does Z look like? Z we didn't put anything on.
Z is just a parameter, right?
Yeah, where is he?
It's at the bottom, the constructor.
Yep. And it's never used anywhere else.
Weird. So it completely elided it. You have to send it in as part of the constructor, but it didn't even generate anything to hold on to it. That's kind of cool.
Yeah.
So we can already see optimization phases that Scala is going to turn into.
Well, is that an optimization? He's just preserving the type signature.
Yeah, he's preserving the type, but you pass it in and Z doesn't go anywhere.
Yeah,
Right, but I'm saying that's, you said optimization, but I think the JVM would do the same thing, right? It's not eliminating anything.
They didn't put in it didn't put in, for example, the accessor. So the accessor's not up above.
Yeah, but that's only because there's no val or var.
Right, but it defaults to an immutable when you don't have it.
Oh, I see what you're saying. It only exists for the bar body. You're right. There would be no reason to put it out there.
Yeah, the getters and setters are only going to be created for the vals and the vars.
Yep, you're right.
So we don't have a method, a body here. So like if I were to create a new bar from Java and call this constructor, nothing actually happens. That seems wrong.
It does, doesn't it?
So
Where is it setting this dot A?
Well, go back to your code. Do you even use the constructors?
I don't, but the
You
constructor
don't
should
use-
still be
no, you
filled
use
out so that I
A
can call
times
it.
C.
Oh, interesting. Well, that could be another just dead code removal thingy, right?
No, I mean that code has to be there in order for me to use it from Java.
Oh, you're right. They'd have to. That's weird. So
it
what the
has to
hell are they?
exist. What is going on?
Okay, did it inherit? What did it
Private
inherit?
double lazy compute. Since it's lazy,
No, that's just D. I mean, if I instantiate one of
you
these
don't have
guys,
anything happen
call
unless
new
it's
bar.
lazy.
So let's.
Well,
If you take the lazy out, then something will happen. But since the only thing that's really evaluated is the D upon accessing it, nothing
Well,
actually
he's-
happens.
No,
So-
it should still have an A.
You don't have to store A because you only need to store A on the evaluation of D.
A is still a var though. Looks like a bug to me.
You don't need the U for a case class.
It's not a case class.
That's not right.
Okay, so that looks like appropriate Java.
Oh, where's our var? There. Yeah, it's still empty. See, I was going to say it's almost like a bug in the decompiler.
So this looks like the decompiler can't understand what's going on.
yeah.
Does anybody understand why that might be happening?
So there's probably a synthetic method that's supposed to be injected at that point to do the assignments, I would guess.
So, what is the first thing that every constructor that inherits from something has to do? And every method implicit, or every object implicitly inherits from object.
Super?
Super. Does Scala do that?
Well, implicitly.
No, it doesn't. Because Java enforces super as the very first thing that you do.
If you're going to use super, you must make it the first thing. You're
But
not
the
required.
JVM doesn't. This is like one of the major differences between Scala and Java, is that if you try, and we actually ran into this at Bottle Rocket, if you inherit from an object and you try and call anything other than super, it fails in Java. So what happens if you're trying to instantiate an object whose constructor relies on a virtual method call to data that hasn't been set?
They're all nulls.
Problems.
It's all nulls and you're screwed.
Yes. My enumeration, the enumeration I implemented, I hit that problem. That's the problem I hit.
Yep. So what happens with Scala is it says, fine, I'm going to set everything first, then I will call super, so that you can use these bloody virtual methods in your constructors. But that's not valid Java. You can't write that in Java, so it doesn't render it. So let's
Oh,
see.
so the decompiler can't show it in Java since you can't write it in Java.
Right,
Is that where you're
so-
going with that? I got
yes.
it.
So let's see if we can figure out using bytecode viewer.
Yeah, that's the next thing, is it could drop down to the bytecode and watch what it's doing.
Let's see if this goes. So this is the bytecode here. I apologize if it's small.
Yeah, you have to scroll down towards the bottom, I think, before you get to the constructor.
Yeah, but I want to see if I can make
Oh, there you go.
Oh, nice.
Yes, I would like to make the font size bigger. Apparently I
Return?
have.
Open it again.
There's a refresh down at the bottom in the middle. Does that have anything to do with it? There you go.
Yes. Oh, thank God. Okay. Well, maybe I can use this. Okay, so where's
There's
the
your constructor right
There's
there.
our constructor.
Yep,
right here.
and it's showing all the details.
Okay, so what are we doing? Are we doing, here's our
Yeah.
vars, here's some local vars.
But there's the load into A right there, third
Yeah.
item.
I like the comments.
Yeah,
Yeah,
Oh,
the comments are
It's
helpful.
like old school assembly.
yeah.
yes, it is.
Okay, so here we're actually setting all of our fields, which is what I said happened, and now we're actually going to call super, which is this invoke special on object. And then we go off and do other stuff because we actually had code in the body of here. And this would be other code that we would run as part of construction.
Yeah, there was something like set C.
Yep.
So the L1, L3, L4, those are labels to jump at, right? And up there in the local
Think so.
bars, it refers to them.
Yeah. So this is something which I never fully appreciated until we actually ran into this problem at Bottle Rocket, where somebody had put together a really nifty class hierarchy and then needed to instantiate something through the constructor. At least that was the most appropriate way to do it. And just like, you cannot do this in Java. You're deadlocked. But in Scala you can, because it does it the right way.
That was a cool tangent.
It's one of those things that you don't realize that Scala gives you until you actually see how it's implemented and the problem that it solves. It's really neat. All right, so what else do we get?
It's crap like this that probably spawned the motivation to produce Tasty. The whole wanting, in other words, how looking at how the composition occurs in pure Scala before you actually, because once you drop into this, you start removing the ability to go backwards.
Oh, yeah, I mean, there's a lot of type information that just gets completely dropped.
Right, yeah, that's what I mean, yeah, exactly. We
Yeah.
couldn't decompile it, right?
Yep. All right, so let's go back to this because I like that rendering better. What else about bar should we look at? Oh, lazy, great. So lazy is one of those really interesting things in Scala. So this is how they're computing it right now. They grab a mutex so that if you have two different threads that try and instantiate it, it'll block appropriately. Then it looks at this bitmap thing to see, okay, so that's just a Boolean which is going to be set, so it's going to be false initially, and probably it'll be set to true once we actually instantiate it, and which happens. So yeah, in the block, we do our code, we set the bitmap, and then we return the value. So there's all kinds of fancy things that happen on this. So our synthetic method for our getter under here is looking at the bitmap. If it finds it, it returns it. Otherwise, it calls our lazy method.
So, since it refers to A, An A is a var. Oh, is it a var parameter?
But everything here is still using the methods, right?
Right, so if you go up, and if A is not synchronized,
It's not.
oh, because they synchronized on this.
So they're using Java JVM semantics. So if you have multiple threads doing stuff and A is changing out from underneath you, it will let you shoot yourself in the foot.
Isn't that wild?
Yep.
Now, if A changes, that doesn't necessarily call D to recalculate.
Oh, no, not at
well,
all.
but because A is a var, and anybody in the world can be setting it,
Yeah.
you don't know when D is going to be instantiated.
Right.
It will let you shoot yourself in the
So
foot the
D-
same way that Java would.
D takes its value the first time, and then if A changes after that, it does not change.
Then we'll never see it again.
Yep.
Right, interesting.
So lazy vowels should basically only have concrete values.
Yeah.
Yeah.
Well, they should, yeah,
I
they
think
should.
just from a concept standpoint, right?
Yeah, yes.
That's interesting.
Yeah, in other words, the implication of a lazy val is that it is immutable. And should only take immutables.
I think
Or
it's like
only
a best
take that
practice
first
thing to do,
one.
right?
Yeah, oh, absolutely.
Yeah, if you're instantiating a lazy val from a var, that's just a bad idea. I wanted to just render out what that would look like and tell you just like,
So from an
this is as bad as you would imagine.
And from an efficiency perspective, you don't synchronized on all the other methods to block, you get all the overhead of the mutation
Oh, yeah.
access. So by doing it this way, basically they're saying, you want to screw things up? Fine, we're going performance and you're just making multi-threaded madness. Okay.
D adds a what? 2 switches for the first one, and then another switch for any subsequent one. So there's a lot of overhead just to access it after the fact.
No, after the fact, it's a simple bitmap look
But
up.
still, I mean, that's still one computation on top.
Yes,
of
that's a, yeah. It's,
double your
Well, so it's one if statement, right?
right.
Which is going to execute in one clock cycle.
Right.
So the only thing you might possibly have to worry about is if this is in a different location. So like if it wasn't, what you're really worried about right now is data locality. And so this is why objects shouldn't have identity and other things in JVM. But Hotspot might be able to do static analysis on this and say, it's only ever set to true in one place, it's in this one particular code path. I know if you go through this code path that this is just always going to be true, so maybe it can de-optimize that if away.
I hope they do that down actually at the JVM level itself, where it's something that you can, in other words, that there's a marker to say, this is a one-time use pathway.
So yeah, what would be the use case? Why would I ever want to use lazy?
If you have a computationally heavy field
Well, like
that only
something-
needs to be
okay.
calculated once.
Yeah.
It won't
you
be
may or may not
calculated.
access
So
it.
for example, if you had something that was in a compressed version of a document, if you and that lazy was the reference to the decompressed version.
Right.
If you're loading crap tons of these off the network and you're going through a bunch of stuff and you only occasionally ask for the decompression, you don't want the overhead of
Maybe
the
like
space.
taking a hash value of like a large object, since the hash value would take
Yeah, I
time
mean,
to
say you have a
calculate.
list of-
That's another one. That's
Yeah.
computationally intense. Yes.
Yeah.
Yep.
All right.
You could probably do some really cool tricks to confuse your coworkers with this.
Yeah.
Cool tricks.
Yeah. Yeah. As long as you're the originator, it's very cool.
Yep. You mentioned something about synchronized. One of the things I noticed is nothing in here is synchronized. And like none of the vowels, none of
No,
these
there's
getters.
I saw something synchronized.
Well, yeah. The only thing that
Lazy.
synchronizes
This.
that.
Right.
What?
Only that.
Well, that was my point. My point was they didn't put synchronized on the methods so we can get,
Exactly.
and that's an efficiency thing. They don't want the mutex all over the place. They want it in the only place it is, which just means if you don't put synchronized in other places and you do expect to do mutation, you will foul this up in a multi-threaded environment.
But it's also easy to see in here. Oh, what were you going to say?
I've never actually done Java, so what does that volatile mean?
It tells the CPU that it can't make too many assumptions about where the memory lives. So like if you have
Yeah.
multiple CPUs,
Okay.
he can't assume that CPU 2 can't assume that the last time he got that data, it's still valid.
Oh.
Yeah, it's a forced cache refresh.
Yeah.
That's what it
actually,
does.
from a performance standpoint, that's actually one of the things that you really need to take into account in the double D where it says this dot bitmap 0. So this .bitmap0 is always going to force.
Yeah, it's always gonna fetch it from range.
That's right,
instead
that's
of
right.
And that is actually one of the reasons they recommend don't use lazy val unless you have to, is literally that, the public double D, where it says this .bitmap $0, that will cause, in a multi-processor environment, right, it will force the, whatever processor that is making that particular instruction, it forces a refresh from whatever the memory was.
JVM better optimize that away then.
That's what, well, that was my point.
Yeah.
If the JVM can introduce an instruction called a one-time touch, if it can actually, if they'll introduce that conceptually and then implement, it can be the same implementation behind the scenes in the JVM. Eventually, they can do a thing where, if you think about the assembly language, you've got basically the entry point's a test, and then it's a jump. And if you place the value right behind the jump, if the jump basically places the value and allows the execution, you can rewrite the entry point to just be a hop over the function. And now you got a no-op instead of all the overhead of an actual Boolean detect.
JIT might actually do that already.
I hope, I read the crap out of it. There's nothing, at this point down in the JVM, they haven't, and it's not because Java doesn't have this concept. So, at least so far. That's why I'm eager to see them change that. Because we're not the only language that has that need.
So the other thing they might be able to do, I don't know how many free bits they have in the object reference. But if they have any free bits at all, what they could do is take volatile bits in the object reference and just lift it up into there so you always have it local at least. So even if you still are forced into doing that if and that jump, at least the data is with the object reference rather than God knows where.
Object reference of D?
Well, no, object reference of
object
this.
itself.
But the
So,
challenge there is you can't guarantee that it won't. So the problem you have is the CPU A is the one that is.
They should both have the same reference loop.
What? No, not an L2
Have the
cache.
same pointer that should have.
So the purpose is that
Yeah, they might not have
L2
that.
does not do a memory fetch until it's told to do a memory fetch. That's how that works. And so if the last time it saw this,
No, I'm saying the two different bits should be local together, and that makes a lot of this problem go away.
2 bits. What do you mean the
So you have the pointer to memory, right, to your object. That actually has a header in it.
Yep.
That header, if it has free bits in it, could have a free bit that is your bitmap.
That is what that is. That is.
No, this is a field in the object, which means it might live someplace else. And a lot of these fields don't remember that they might have other further pointers for things off.
I see. Now that would bring you into the object, but again, that's assuming that even that's still a reference. You're still in a reference on
Right,
that.
so now you've got pointer. So, because you've got the pointer into the
Yeah.
object itself, and then pointers for each of
This
the
is all
fields.
this doing justifying my argument. Get it into the JVM, hide it behind the thing,
Exactly.
do a damn instruction that does that.
Yeah, so this would actually also get solved if they ever get up for Tuckus and do the two.
Well, the fact they did Invoke
Or the data
Dynamic
classes.
Invoke Dynamic shows they were receptive. Hopefully they'll go this next step.
Yeah.
I think it's called a thunk, by the way. That implement, that's how they did it in Haskell. That
No, I mean, a thunk is a complete bit of code that you can execute that isn't,
but it
doesn't have any arguments into it, any memory that you need to
Oh,
set.
okay. All right, then it's not thunk.
All right, so
They've
that's,
limited the efficiency in Haskell. I don't know what it's called.
oh, by the way, do folks have like another, let's say 20 minutes? We'll get through as much as we can. All right, we'll get through as much as we can. So that's Bard. It's doing lots of magic underneath to make life nice. But obviously the special sauce that we all know and care and love about Scala are our case classes. So we've got a case class here which wraps up a single field called X. I think it's compiled down into what? Drum roll, please. Well, we can already see that we're being lied to because our case class is suddenly two different things. It's foo and foo dollar. So what is often foo? And what does foo look like from a class perspective? So here's our class foo. We can already see that we're pulling in product and serializable. So we know that we're going to have Java serialization capabilities on every case class that we have. We'll look at product in a second and see what it gives us. but we can see that it's coming in from Scala.product. Here's our X. We know that it's final, so all of our case classes are always immutable. We can see that we have a reasonably named constructor, so we'll be able to access this from Java, and it will do what we expect. And then we call init, which is going to do interesting things, I'm sure. And then here's a lot of the just free stuff that case classes give us. So it gives us a reasonable dot equals. It gives us a very interesting implementation of toString. I did not expect this. Gives us a hash code which uses a completely random seed. Okay. Probably. I hope. I wonder what this is doing. Finalize hash.
It's a mix on an X value.
Yeah, this is interesting.
With
Well,
a
X is
C.
the X we passed in.
Yeah, X is the X
So
we passed in. So we know it's the hash code is going to be a function of our
input.
inputs, our fields.
Plus the seed. Does that seed change every time you compile, or is that always?
I don't know. It
I
might.
don't think that it could.
Oh yeah, you're right.
Yeah.
It couldn't.
It needs to say the same.
Yes,
Yeah.
right.
So
It
what-
could be a hash of your class name or something,
Yeah.
and the fields that you have.
My guess is it contains the fields.
Yeah.
Well, there is a formula for generating the seed for a hash, and it's really specific, but I can't remember what
Well,
it is.
that would be
right
an
now.
optimal hash.
Yeah, for optimal, yes, for an optimally distributed hash, yes.
Yeah, maybe this is an optimal hash. I don't know.
Yeah.
We have a product iterator.
I think that one's specifically for implementation of product.
Yep,
probably.
it is.
And then we
Just
can get
erase
a
all the
product
variables, the parameters.
elements.
What is this? I wonder if this facilitates the tuple, like the representation of.
Yeah, this is all for product, so you can reference the third or the fourth.
Right, yep.
You know, by index.
There's only one in this case.
Mhm.
It seems like reading this code, that this is always going to throw. Am I wrong in that? Because
Yeah.
you don't have anything other than a default method.
Mm-hmm.
And the constructor also is throwing away, or the constructor at the very top of the file looks like it's throwing away the input. So I think there's something else happening there too.
Yeah, so let's go look at,
Will you go back?
ah. What are we looking for?
Oh, you're gonna go to the other tool?
Yeah.
Yeah, that's all right.
Oh, okay.
Sorry.
It doesn't make any, yeah, we're missing something.
So this is just giving it very different.
There it is, product iterator.
Well, I wanted to look at the constructor first.
Mm-hmm. Right
Okay,
there.
so here's the constructor.
So
Oh,
there's the
right,
hook
the
field right there.
constructor's gonna be the same
It's the same
as-
problem we had last time.
Yep.
Yep.
Okay, well that helps.
Invokes the super product.
Interesting, and so after doing,
So it goes off first.
So that, notice it loads a load, the next statement, right, after that is the loading of the reference to the self, and the invoke static, the init is getting past this, and then that's how it has access to X.
right. So it's calling super on object, and then it calls product dollar class in it, which is an interesting one. Okay.
Yeah, that's what we're seeing. When you look in the constructor that it did decompile, that's what it found. So if you go look at your decompiled, so while it couldn't figure, there's
Yeah, you're
there's
right.
there's instructions
Yeah,
in
so
front of
it's
that that set up the contents, and so there's invisible to here, X got set in the A load, right? Yeah.
So I'm glad I brought my code viewer
Me
along.
too.
So we
This is
should-
fantastic. It's wonderful.
All right, so let's look back again. Well, here's some more, but let's look at that product iterator. There's product element. I load iStore, so it's gonna load.
It just still goes to your outbound exception.
and store that in two. I load two tables. Well,
Oh, I'll bet one of the switches is not getting expressed correctly.
yeah. it's-
I think it's that A load 4 down below. I'm not, the L4, I believe, is the, that's the what it should do, right? If you ask for element 0, you should get that.
I would hope so.
So why it didn't
I don't-
decompile it, it doesn't make a lot of sense.
I don't see a label for reference.
Oh, there's the box to integer, that's potentially, oh, did it,
Is it going to be a special case with a one parameter case class? Would it change if you did 2 parameters?
No, I mean, you should be able to ask for element 0
Well,
and get
like,
that element back out.
right?
well, L4 is doing that, isn't it?
Yeah,
L4
L4
will,
is
but how do you
giving you
get there?
0. But I think it's
You're gonna
saying
drop into
since you
L1.
didn't define it as kind of the
You're gonna do
list
this.
type.
There's
Table,
no-
oh, you're right, there's no jump to L4 is what you were
Right,
saying.
There's no jump to L4s. How do you get there? I don't understand it.
That's a good question. Well, you can always whip into a Scala worksheet or REPL and try right quick. It obviously works.
Well, since there's no more
That's a
than
good
one,
question.
would you ever try to index into it? Like they with the element? Like
He's
with the
going to
clock?
do it right now within the console. Basically, what happens if you have that case class and you ask for the...
Okay, so we're going to do
You don't have to do new, yep. If you want to put it to a value, you're just going to grab the resource. So it worked, clearly. Yep.
Okay, so it's working, I just don't, it's not
How?
obvious how. Okay, well, I'm
Does
willing
it
to trust.
override that method somewhere, perhaps? What are
No,
the-
because we're looking in,
We're looking at the
Yeah,
implementation.
that's it.
Yeah.
That's it.
Can you just search for L4, maybe you don't see it somewhere on
Yeah, maybe it's really far in the right margin.
They're in a chance that,
it's possible, but I don't see it. Huh.
I love what I store table switch default.
so on a table switch,
Three, new-
does table, I don't know the,
That's what I was just wondering, if table switch has a fall through with 0 by default or something.
right, exactly, right. In other words, is table switch require that you articulate each of the switch points, or it signs default and then the rest is interpreted? No, that doesn't make any
Default
sense.
is going to be any argument, right? Or it should be any argument, or any argument that you don't explicitly call out before that.
What's L1?
When performing a table switch, the int value on top of the stack is directly used as an index into the table to grab the jump destination and perform the jump immediately.
Oh,
There you go.
well, except 0 is L3.
The default is L3, but 0 is on the stack.
Oh, so 0 technically starts with the first item after L3, is that what you're saying?
I think. I'm not certain. So if I do switch above is perfectly compatible because in numeric hold, this column will create a
That's fascinating.
this.
Yeah, let's push on,
Yeah.
just because we'll get stuck on this. So here we get an iterator around it. And equal, so this is a more generated code. Let's actually look back at the generated code, because that's just easier to see.
Can equal,
I
you
think
just
there
asked
was-
it.
there was-
Can equal requires it be the same instance of, the can equals,
Oh, yeah.
that's, it has to be, they have to be equivalent types.
Yep. And we can see that our case class isn't lying to the JVM. It really is food. It's not food all or anything. Product arity is 1, so that's just hard coded. Our product prefix, like a lot of these methods, like how many people use these and what are they using them for? Like, that's what I would love to know. I'm glad that they exist. Like they seem really useful.
Well, like when you shoot out a case class through the toString function, I know some of this gets used, but I don't get the product prefix part. That makes sense.
Oh, here's
No,
our
two
defaults
strings
for
isn't-
the magic of the copy method, which all get instantiated.
I
Here's
think
your
that,
copy.
I think that toString is the only thing that really uses the product stuff. Because product prefix, it would need that for toString.
Oh, yeah, I bet
Product
toString
element
uses it.
and all of those.
Yep.
But it probably just uses product iterator, and product iterator probably gets the iterator using product element.
Oh, yeah, and so it just emits foo, open parentheses, and then the iteration of the, that makes sense. Yep.
Yeah, that probably is exactly what it's doing.
And that's probably passed off, they probably have, there it is right there.
Yeah, like product iterator.
Yep.
Compose, and then here's our magic apply. Is that what it means? All right. So what is food dollar?
Wait, foo has an apply? You can call apply on a.
Yeah, okay, oh, yes.
Apparently, you
It's the
can.
constructor. Apply
It's
is
to
the-
make things easy from Java.
So you can call the constructor on an instance.
No, it's static.
No, it's not a constructor.
Oh, it's that.
Yeah, well, it,
I'm not used to Java.
so, but apply on an instance of a case class is what,
Well,
is
you
an
wouldn't need an
ability.
instance because it's static.
Yeah,
Static, it just builds one.
yeah. I can't read. That's the problem.
Oh, from Java, that's how you would do it, but the apply
Yeah.
method's sitting on the instance that you've got, that's, you have an instance, it has an apply method, you pass it a value, it's the equivalent of, if you were pass
The
it,
equivalent of copy, yeah.
yes, it's equivalent copy, yeah.
Okay. So now what does this look like?
But this is the object, so in Scala land, this is object foo, and this is what object foo would look like if we, so this is an implicit companion object expressed as
Right.
opposed to an
This is your
explicit.
companion object.
Yeah, exactly.
So,
But it's an implicit companion object since we didn't explicitly create one.
If you were to create one, would it just append its methods to the end of this one?
probably.
So there's a rule set for it. There's actually, when I was writing my, I did the presentation on using my case class pattern. And so, for example, the apply method that you attempt to generate in your explicit companion class conflicts with the one that it would automatically generate and blocks you from creating it. So that's when you have to do an abstract case class to block the apply method from being auto-generated. Does that
Let's
make
see
sense?
what happens when we do that.
Yeah, that'd be awesome. There's a Stack Overflow thread on this particular subject. Me and a professor at some university went back and forth.
So we'll do a case class baz, and then we'll do an object baz. And here,
Apply.
call them twice, and we will take and return 2 times baz.apply. Just to have it do something. Okay. Alright, so here's our baz, here's our y, here's all the stuff that we're doing. So where does twice exist? So
Right
twice
there.
exists both here as a static method in baz, but notice where it's calling off to. So this is obviously to make Java easier to write, or your life easier in Java land and call off into Scala land. So that you don't have to know about these bloody damn module dollar stuff.
Oh, I see. As long as you've already got an instance. Well, no, you don't need an instance.
You don't need an instance, but the Scala looks the same as the Java. Is I
Okay.
think why they're doing this. Or at least as similar as can be. All right, so now here, we're doing the $2, but does this companion object look the same as our other one? And I can already tell you no. So here's our foo dollar, which is the Scala generated one. We can see that this guy inherits from abstract function,
And we
whereas
did
our
not.
Baz one doesn't. So
Yep.
we've already got